we're going to learn how to solve trigonometric equations with factoring. And so before we get into like the actual meat of the lesson today, we're going to review some factoring techniques that we may have not forgotten, but may have left out of our mind since Algebra 2. And so the first step of factoring, or the first attempt for factoring, should always be a GCF, which stands for greatest common factor. Good job, Ethan. And so we need to look in our problem and see what is something that we can pull out from both of these quantities. So we have x squared y minus y. So what's something that's in both of them? Y. So we can pull a y out. And by pulling one out, I really mean we're dividing each of them by y. So we're dividing x squared by y, and we're dividing y by y. So x squared y divided by y is just going to be x squared, and then negative y divided by y is just going to be negative 1. So we have x squared minus 1, and then our y is now on the outside. So this is actually not completely factored all the way. There's one other step we can do, and some of you might have noticed it, some of you might have not. So this x squared 1, he is a difference of squares. So when it's a difference of squares, we can split it up into two factors with one that has a plus in the middle and one that has a minus. And we have to take the square root of each piece. So x squared, the square root of x squared is just going to be x. And the square root of 1, so it's going to be 1. And so we have x plus 1 and x minus 1. And then, of course, we have our y that's still on the outside. So now we completely factored x squared y minus y. So hopefully this will get your factoring juices flowing back in your mind so you can come back to the factor masters that you guys were in Algebra 2. Oh. So problem number 2. What should be the first step that we should take when factoring? Our first attempt while factoring. What do we need to do? We need to find a GCF. So is there a GCF with this? Y. So we can pull y out of our first quantity, so we have 2x, and then y out of our second, so we're left with just 1. And then that's all we can do. We can't factor it any farther, so you did it. Good job. Okay, so do we have a GCF for this next problem? So we have an x in the first one, but we don't have an x in the second. So it's not a GCF, but it's a difference of squares. If we look, we have a square here, and this is a square, and then difference means subtract, or the answer between a subtraction problem. So we have a subtraction and 2 squares. So x squared is going to be x. And then what is the square root of 4? 2. And then the square root of y squared is going to be y. So we have x plus 2, or x plus 2y, and x minus 2y. So hopefully this is starting to recall, and your math minds are starting to turn, and you're getting back to where we were. So now we're going to go to another step that we learned in Algebra 2, which is factoring quadratics. And I learned a different way from when I was in high school to what you guys may have learned. So I am still getting adjusted to how you guys are doing it. And so Mrs. Danhoff today taught me the what is it? Slide, divide, bottoms up. And so
show them your method, and then if we need to, I'll come up and do our method.
should I do split the middle?
You can, some of them have seen split the middle. But
Okay.
do what you can do. Like, you don't need to do anything special, hopefully, on this one.
Right.
But
And so the first step we need to do when factoring is, or the first step that I was taught to do while factoring, is you take A times C. And so our A is really just a 1 in front of our x squared. And then our C is negative 2. So we have 1 times negative, or 1 times 2, because we won't worry about the negative at the moment. So 1 times 2 equals 2. And now we need to think of some factors of 2. And sadly, 2 is a prime number, so it only has 2 factors of 2 and 1. And so now we need to think, what are 2 numbers, or which of these factors, which there's only, can we combine together to get our middle number, which is negative 1. Sorry, that's supposed to be in front of the x. Oh. Whatever. Okay. So how can we take 2 and 1 and get it to equal a negative 1? How can we change the signs? Yeah, so we can have a positive 1 and a negative 2 equals negative 1. So we're going to split the middle and take x squared plus 1x and then minus 2x minus 2. So we didn't really change our problem at all because 1x minus 2x is the same as negative 1x like we had before. We're just rewriting it in a different way. And now I'm just going to split the middle and draw a little line down our center. So do we have a GCF in the first half on our right? Or on our left, I'm sorry. So what GCF do we have? X. So we have X, and we're left with X plus 1. And now on our second half, do we have a GCF? We can actually pull out a negative 2. If we look, because we have a negative 2 x and a negative 2, so we're left with just positive 1. And now we have another GCF, because GCFs are the best. We have an x plus 1 and an x plus 1. And so we can pull out a whole x plus 1. We're left with x minus 2. Not quite, because if we were to divide by x plus 1 and divide by x plus 1, like what we do when we factor out, and we're left with just x and negative 2. Oh. Chloe, did you have a question?
Yeah, no, since you're taking out the negative terms,
And so we need to remember back up top is that this was all equal to 0. And so there's a rule called the zero product property, which just allows us to set x plus 1 equal to 0 and x minus 2 equal to 0, and then we solve. So we subtract 1, and we get x equals negative 1 at 2 at 2, and x equals positive. X equals 2, sorry. And if you were to go from this step straight here, that's fine. You're all smart pre-calculus students. If you skip that step, we're not going to hold it against you. So hopefully this is starting to come back to you as well, and factoring is starting to flow back in your mind as well, because we're going to use it a little bit. So let's try this next one, and then we'll get actually to the real meat of the lesson. So first thing we need to do is take A times C. So we have 2 times 1, which is another 2, which we know just from the last problem. And our factors of 2 are 2 and 1. And then we have another negative 1, so these are actually going to be the same factors of negative 2 and positive 1. And so we're going to split our middle and rewrite it as x minus 2x plus x minus 1.
No, she was just confused.
Okay. Just on the method, or?
You just use a different method than what
Okay.
I'll do the new method.
Just keep going up.
How do you get the 2x squared minus 2x?
So the 2x squared is from above. What we did is we took negative 1x and we rewrote it as 2x, or negative 2x plus 1x. Because those are equivalent, and so we can rewrite it as just a different form. And so we're going to factor out our GCFs, and so we have a 2 on our left side, so we're left with x minus 1, and then on the right side we just still have x minus 1. We can't factor out anything. And this is all equal to 0 still. And so we have 2 x minus 1s, so we can factor out an x minus 1 from both sides, and we get x minus 1 on the outside, and then 2x minus 1 divided by x minus 1 is just going to give us 2, and then x minus 1 divided by x minus 1. Wait, oh, I lost an x, I'm sorry. This supposed to be x. So this is 2x, and then x minus 1 divided by x minus 1 is just 1. So we can do our zero product property and have x minus 1 equal to 0 and 2x plus 1 equals 0. And if you skip that step and just go straight to the next step, it's okay. But we need to add 1 and add 1. So we get x equals 1, and then we subtract 1, and we get 2x equals 1. 2x equals negative 1, and then we divide by 2. Divide by 2, and we get x equals negative 1 half.
So let's try the method that you did last year, conceivably, which was slide, divide, bottoms up. And we are going back to split the middle. Not that you need to go back to split the middle, but there is a fundamental flaw in this method. And it's not impacted here, and it's oftentimes it works, but it doesn't work every single time. So that's why we're splitting the middle. But here's an alternative way to work this problem. And what we did is we take this 2 and we slide it over. When we slide it, then we're going to get x squared minus x. The slide means that we're going to times by 2. So 2 times 1 is 2, and then there's that negative or that minus sign out there. And what happens when we do this slide divide is now we've got x squared. So we don't have to worry about the number in front of it. And we can break apart x squared as x times x. And then what Mr. Jarvis was talking about with that 2, it's the same thing. There's the 2, and the factors of 2 are only 1 and 2. And to get the negative 1, what we've got is we're going to have positive 1 minus 2. So we put that back in here. Plus 1 minus 2. Well, we slide, but we need to divide. And what we're going to divide by is the number that we slided, terrible English, by, which is the 2. So we're going to divide by 2 there. And when we do, so now we've got x plus 1 half. And then we simplify this. 2 divided by 2 is 1. Now technically, with the slide, divide, bottoms up, to solve this one, you don't really need to solve it. I mean, you don't really need to do the bottoms up, because a lot of people can look at this and go, oh yeah, the answer is x equals negative 1 half and x equals 1. But I do want to show the bottoms up just in case we need it somewhere else. And that is, we would take this value up here. So then it would become 2x plus 1. And it would become x minus 1. and then the zero product property. You set each factor equal to 0. So it's 2x plus 1 equals 0, x minus 1 equals 0. And again, if you don't need to show those steps, it's fine. And over here, we get the 2x equals negative 1, and then we divide those sides by 2. And then we end up with x equals negative 1/2. Slide divide will work for us. Split the middle will work for us. Back to Mr. Jarvis.
Okay, so maybe that was a little bit better refresher for some of you who learned that method. So now we're going to start actually solving the trigonometric equations using these methods that we've learned in the past. And so we're going to solve each equation, but notice that we want to use the general formula for all the solutions. So what we learned yesterday with the plus 2 pi k or the plus pi k, we're going to use that general formula. That way we can get all the solutions. So hopefully you have that still in your mind from yesterday as we continue along through this. And so, what is the first step we should try when we want to factor? What's the first attempt we need to do? GCF. So do we have a GCF in our problem? So we have a cosine in both of them. So we can take a cosine out, or cosine of theta. And so we have sine theta squared, and then we have cosine of theta divided by cosine of theta, which is just 1, and this equals 0. So now that we have cosine of theta and sine squared of theta minus 1 equals 0, we can do our zero product property and split both of them up and equal to 0. So we have cosine of theta equals 0. Sine squared of theta minus 1 equals 0. So we need to get the variable by itself before we can use our working backwards method and find all the solutions. So we need to get sine squared theta minus 1 just as sine of theta. So what should be the first step to get sine by itself?
Plus 1.
We can add 1 both sides. And so we have sine squared theta equals 1. And now how do we get rid of that squared? We need to take a square root, because the square root is an inverse operation, so we'll get rid of our square, but we have to do it to both sides. So we have sine of theta equals, what's the square root of 1? Plus or minus 1. So every time we take the square root, we have to remember plus or minus. So I'm going to extend the page up. If we remember, we also had, oh, it's on the other side, come back to me. We also had cosine of theta equals 0. So I'm going to write that below. So now we have to think, this is the working backwards. When is sine of theta positive 1?
Pi over 2.
Pi over 2. And when is sine of theta negative 1? 3 pi over 2. So on our unit circle, because we're solving for all of the solutions, not just these two, we have pi over 2 at the top and 3 pi over 2 at the bottom. And these, if we were to form the line, make a diameter. And so, because they make a diameter, what are we going to add on to this line? We're going to add pi k to the smaller angle. So we have theta equals pi over 2 plus pi k. And that's for our first one. But we also have cosine equals 0. So when does cosine equal 0? So pi over 2. Is that all? And 3 pi over 2. And so it's actually the exact same points as the ones we had before. So this answer would also be theta equals pi over 2 plus pi k. And that is all of the solutions for our quadratic inequality, or our quadratic or trigonometric formula that we had before. Sorry, I got algebra 2 on my mind. So that's all the solutions for sine squared theta, cosine squared theta, or cosine minus 1. So let's try another one. So now we have 2 sine theta, cosine theta, minus cosine theta equals 0. So what should be our first step when we want to solve GCF? So do we have a GCF? Yes. We have cosine of theta. So we can pull a cosine of theta out of each of these. That's the same as dividing them by a cosine theta. So we have 2 sine theta divided by cosine theta is just going to be 2 sine theta. And the cosine theta divided by cosine theta is just going to give us 1. And now once again, we can set both of them equal to 0. So we have cosine of theta equals 0. And we have 2 sine theta minus 1 equals 0. So how can we start to get this 2 sine of theta minus 1? How can we get the sign by itself, or isolate the variable? Add 1. Add 1. Add 1. And so now we have 2 sine of theta equals 1. We have one more step to isolate the variable. We're going to divide by 2. So we're left with sine of theta equals 1/2. But like before, we still had another one, which was cosine of theta, which already had the variable isolated. So I'm just going to write him underneath. Cosine theta. So when is sine of theta 1/2? So sine of theta, just in the first quadrant, is pi over 6. Where else is sine positive? In the second quadrant, which is 5 pi over 6. So we can draw our unit circle. 5 pi over 6 is roughly about here. Or pi over 6, I'm sorry. And 5 pi over 6 is over here. So if we were to connect these, do we get a diameter? No. So what do we have to add to the end of each of them? 2 pi k. So we get pi over 6 plus 2 pi k, and theta equals 5 pi over 6 plus 2 pi k. But we still have cosine of theta equals 0. So when is cosine of theta equals 0? Pi over 2 and 3 pi over 2. So just like our last problem, that's a very oblong unit circle, but our pi over 2 is at the top, and 3 pi over 2 is at the bottom. You can draw a line, and if it were to go to the center on my drawing, we would get a line that is a diameter, and so we know that we need to add what to the end? Pi or pi k. So we have theta equals pi over 2 plus pi k. And so all of these are our answers for our trigonometric equation that we started with. So we have a lot of different answers. for this trigonometric equation. And so, starting with this second one, a nice thing about this one is it's already factored for us. So we don't have to worry about that stuff. Like, there's nothing new that we need to do. So what should we set both of our factors equal to? 0. So I'm going to change my colors and get a nice pretty color going. So we got cosecant of theta minus 2 equals 0. And actually, I'm going to write it over here. Cotangent of theta plus 1 equals 0. And so on our left side, how can we get cosecant of theta by itself? We can add 2. And so we're left with cosecant of theta equals 2. And then you may be like me or Mrs. Danhoff, and I don't know cosecant of theta equals 2 off the top of my head. So I try to think of the reciprocal. And so what's the reciprocal of cosecant? Sine. And so we have sine of theta equals the reciprocal, which is the flip version of 2, so it's going to be 1/2. And so when is sine 1/2? Pi over 6. And then 5 pi over 6. Which is the same we had last time. And so on our unit circle, we saw last time that we had pi over 6 here, 5 pi over 6 here, and they did not create a diameter. So we're going to take the smaller angle and add pi k. So we have theta equals pi over 6 plus pi k. Oh, I'm sorry. You guys are right. Yep. So we're going to take both angles and add 2 pi k. You guys are smarter than me. You should be up here teaching. So theta equals 5 pi over 6 plus 2 pi. Okay. So that was the answer for the left half, but we still have the right half. Go back to my color. And so how do we get cotangent by himself? And subtract 1. So we have cotangent of theta equals -1. And once again, I also don't know cotangent off the top of my head. So I'm going to take the reciprocal. And so the reciprocal of cotangent is which function? Yeah, tangent of theta. And the reciprocal of -1 is just -1 over 1. If you flip it, it's still just -1. And so when is tangent -1?
3 pi over 4.
3 pi over 4.
And 7 pi.
And 7 pi. So if we go back over to our unit circle, we find 3 pi over 4 and 7 pi over 4. They do create a diameter. And so we're going to take our smaller angle and add pi k. So we have theta equals 3 pi over 4. So our answer is the whole, for all 3. Oh, I lost one. Thumbs up, you guys are hanging with me. Thumbs down. Give some of you a moment to catch up. Okay. So now, this next one is a little bit harder to solve, but I think you guys are actually going to find it fairly easy once we get started. So, the issue we have is we have tangent squared minus tangent theta minus 2 equals 0. Do we have a GCF? So we don't have a tangent in our 2, though, so we can't take out a GCF. So we're actually going to think back to a method we learned before I was here in pre-calc called U substitution. And so we can change U, or we can change tangent to U. So we can let U equal tangent of theta, and we can rewrite it into a form that may look easier for us to solve. So every time we see a tangent, we can put in a U, and a U has no value necessarily, it's just a variable, so you can put whatever variable you want. You can put the beginning letter of your first name or your favorite Greek alphabet letter, whatever you want. So we got U squared minus U minus 2 equals theta, so or equals 0. So every time we see a tangent of theta, we're replacing it with U. And so, can we solve this now? Yeah, so this is just a quadratic that we've seen before in the past that we could factor. And so, I'm going to do my best attempt to do the slide, divide, and bottoms up method. And so, we're first going to take our first number and slide it. And so, we have 1 times negative 2, which is just going to give us 2. So, we have 1 squared minus U minus 2. So, it didn't actually change our problem at all. And so we have let's see, is it 1 and 2? I'm sorry guys, I'm still getting my handle on this. And then no. And so we have to think of a way for 2 to go into negative 1, so we're going to have a negative 2 and a plus 1, and now we have to divide by what we slid with, and in that case it was 1, so if we divide it by 1, it'll stay the same, so we can actually leave it as is, and then the bottoms up method is, so this was a bad example to start off with then, I'm sorry guys. Okay, and so we can set both of these equal to 0 now. Oh, I switched my variables, I'm sorry. So once again, U is not important, it's just a variable. And so we can set U plus 1 equal to 0, and U minus 1, or minus 2 equal to 0. And once again, if you skip this step, it's okay, you're just smarter than the rest of us. And so you can subtract 1, and we have U equals negative 1, and add 2, and add 2, and we have, sorry, U equals 2. But if we remember, way back at the top, we said that U was equal to tangent of theta. And so we're now going to get back to our original tangent of theta that we started with. So now we see our U, and we're writing tangent of theta equals negative 1, because we want to end in the same thing in the same variable that we started with. And so we see U equals 2, so we have tangent of theta equals 2. So now, at what value, or what angle is tangent of theta equal to negative 1?
5 pi over 4.
No,
No, 3 pi.
3 pi over 4. And one other, 7 pi over 4. so on our unit circle, we have 3 pi over 4, oh, and then 7 pi over 4, and we can connect the dots, and we make a diameter, so we'll take our smaller angle, which is 3 pi over 4, and add pi k. And so now, when is tangent equal to 2? So Blake shaking his head, because if you look at your unit circle, tangent never equals 2. And so for the second part, we have no solution. And so our only answer is theta equals 3 pi over 4 plus pi k, because the second half didn't have a solution. And
So our last example, 2 cosine squared theta minus cosine theta minus 1. I had to pause the video for a second, so I'm going to start over. We are going to solve 2 cosine squared theta minus cosine theta minus 1 equals 0. We are going to use u substitution again. And this one, we need to be really careful because there's a coefficient of 2 on the cosine squared. So when we start this, we're going to let u equals cosine theta. And one of the ways that helps me figure out which value of u to use is to look at the middle term. So cosine of theta there as the middle term, I check to see if that's a good possibility to use for u, and it is. So when we fill this back in, we're going to have 2u squared minus u minus 1 equals 0. And then we can slide divide to help us solve this. So in order to slide divide, we're going to take this 2, and we're going to slide it over. When we slide it over, that means we're going to multiply by the 2. So it's u squared minus u minus 2 equals 0. And unfortunately, we've seen this before, but it still gives us the good practice here. It's easier to factor when there's no number in front of the u squared in this case. We can break apart u squared into u and u. And then we've got that 2 again. And the only factors of 2 are 1 and 2. And it just so turns out, like 2 or 3 other examples, we end up with, we need to have positive 1 and negative 2. 1 minus 2 gives us negative 1. So we have plus 1 and minus 2 equals 0. But what we can't forget on this one is that we need to divide. What we're dividing by is that 2, the 2 that we slide. So we're going to simplify this a little bit more. U plus 1/2 can't be simplified. And then u minus 2 over 2 is the same thing as u minus 1. And in fact, I'm not even going to do the bottoms up here because it's not going to make any difference here in the end when we go ahead to solve this. So we're going to take u plus 1/2 and set it equal to 0. And we're going to take u minus 1 and set it equal to 0. And we can subtract 1/2 on both sides. So we end up with u equals negative 1/2, and we hope that you don't have to show that step. And over here, we're going to add 1 to both sides, and we end up with u equals 1. But remember, at the very beginning, we let u equal cosine of theta. So instead of u, let's replace u with its actual value, or cosine of theta. So we get cosine of theta equals negative 1/2, and we get cosine of theta equals 1. And then we have to ask ourselves, well, what values of cosine, or what angles of cosine have a value of -1/2. And when we think about that, we know in the first quadrant, cosine of theta equals 1/2 is pi over 3, so it's going to be in the form of pi over 3. But cosine's negative in the second quadrant, which means that it's going to be 2 pi over 3. And cosine is negative in the third quadrant, which is 4 pi over 3. And then we can visualize it in our minds, or we can even make a little unit circle here to determine what we're going to add in 2 pi over 3, second quadrant here, 4 pi over 3 in the third quadrant. And when we look at this, we do not form a diameter. And because we don't form a diameter, what we're going to do is we're going to have to add 2 pi k to each of our angles. And that means that we're representing all of the angles on the unit circle. And just 2 pi over 3 is our first value, but there's an infinite set of values, infinite set of answers here on our unit circle. And then 4 pi over 3 plus 2 pi k. But that was just one of our factors. Remember, we had cosine of theta equals -1/2. But we also have cosine of theta equals 1. So when we think about that on our unit circle, the angle where cosine is 1 is at 0. We don't need to include 2 pi, because if you look back at the very beginning, we're going, 2 pi would be a coterminal angle, actually, to 0. So theta equals 0 is our only choice. So we can write 0 plus 2 pi k. And if you prefer, you can just write 2 pi k. But I like to have kind of a reference back to what the original angle was.